So we're gonna discuss problem 3. By the way, I deleted one problem, so this was the old problem number 4. So we're gonna discuss basically the last problem in our homework section 4.2. So this is a true or false question, and we are asking you to discuss if those statements are true or not. So first one said, I have a quadratic function whose domain lies in between -3 and 3. So basically it tells you that you can't select any other inputs except the numbers starting from -3 up to +3, including the boundary points. So we say you have at least one input which produces the smallest possible output value when your input were chosen from here. So you know how to sketch the graph. The graph of quadratic function essentially looks like this, right? And your quadratic function, I only discussed the definition between 3 and -3. This is a point 0, which is a vertex, which is the lowest point. So since it said I want to include the boundary points, so I'm going to include everything here and everything else in between. It is quite obvious we go through the lowest possible points. So therefore, this is a true statement. So yes, when my input is 0, I am going to reach to the smallest possible output of the function value. And for the next problem, my question is, would I be for the same function when I choose between -3 through +3, excluding the boundary points from the input, would I get at least one input that can produce a largest output for the function value? So when we have the discussion, it's essentially the same idea, same function, but be a little bit careful that it said you should not be picking your boundary points, 3 and -3, so they are removed, and you are talking about everything lies in between. It's quite obvious you will not be reaching the highest point, which is either here or here, so no, you can't find the highest function value. No matter which point you propose as with the largest function value, I can always find something that's slightly larger. For example, if you claim you reach the largest possible function value at the point of 2.999, I could say, no, that's not the correct answer. I could always choose 2.99999 and guarantee you this one squared is greater than the one you propose. So you see where I'm going here? Excluding the boundary points lead to the conclusion that you cannot reach the largest function value. Therefore, this is false. I encourage you to stop here and try the rest of the problems. I didn't discuss everything, but there's one more I'm going to discuss, but I want you to try the rest yourself, okay? So the last problem we have is for a sine function, and it is defined from -1 pi/2 to +pi/2, excluding the boundary points. You should know how trig functions are defined, and you should know the basic graph of sine functions, which goes from 0, and that 2 pi, this is pi, it gets as high as 1, it gets as low as -1. And this point is reached as pi/2, and then the rest part is it's a periodic function. It's just the same shape repeated over and over again, and you know the lowest point is at -pi/2 here. So it said I want you to start from -pi/2 up to pi/2, excluding the boundary points. So everything marked in blue is what you are trying to discuss here, which again, neither the largest nor the smallest output value were reached because they were removed. You will never be able to touch them. So this is a false statement. You cannot find the largest or smallest possible function value. And this is the last one I want to discuss. I want you to attempt the other 2 sub-questions yourself.